Have you ever looked up at the sky and wondered what incredible machines might be soaring overhead, unseen? For decades, the ability to disappear from enemy radar has been the holy grail of military aviation, a true game-changer in global power dynamics. Only a handful of nations have mastered this elusive art: the United States, China, and Russia. But the race for the ultimate invisible warplane isn't just about who has the technology. It's about who has the best and what that means for the future of warfare. Please like and subscribe to my channel. Please comment what you want to suggest to me. That will be the motivation for me to make videos every day. Thank you very much. Now let's get back to the topic. Revealing Russia's most modern stealth bomber, overthrowing the US B-2 Spirit. For a long time, many have pointed to Russia as lagging in this cutting-edge field. Their only operational stealth fighter, the Su-57, often gets criticized for its stealth capabilities compared to its Western counterparts. This perception has led to questions. Can Russia truly compete at the highest level of stealth technology? Well, a new challenger is emerging from the shadows. A project so ambitious, it aims to redefine Russia's aerial prowess, the PAC-DI strategic bomber. But is it a true rival to the legendary B-2 Spirit and the formidable B-21 Raider, or simply an ambitious paper tiger? Let's dive deep into this fascinating shadow war in the skies. The elusive art of invisibility. What true stealth really means. Before we dissect the PAC-DI, let's understand what stealth truly entails. It's far more than just a fancy paint job or a sleek shape. Imagine trying to hide a massive, fast-moving object that generates immense heat and electromagnetic signals. It's a monumental engineering challenge. True stealth is a complex symphony of technologies, revolutionary aerodynamic designs that minimize radar reflection, advanced materials that absorb radar waves, precisely engineered seams and panels that prevent signal leaks, and even sophisticated electronic warfare systems that can jam or mislead enemy sensors. In the 21st century, a truly stealthy aircraft needs to be invisible across the entire electromagnetic spectrum. This means not just evading conventional radar, but also masking its colossal engine heat to avoid infrared detection and missile lock-ons. It's about denying the enemy any information about your presence. The slightest flaw, a misaligned panel, an open weapons bay door, or even certain flight maneuvers can turn an invisible plane into a glaring target. We've seen historical examples like the F-117 Nighthawk, America's first operational stealth fighter, which was notoriously shot down during the Kosovo War by a seemingly outdated Serbian air defense system. It was a stark reminder that even the most advanced technology isn't infallible, and even minor operational mistakes can have catastrophic consequences. The PAC-DI, Russia's answer to the B-2 Spirit? Enter the PAC-DI, or Prospective Aviation Complex for long-range aviation. This isn't just an upgrade to an older Soviet-era bomber. It's an entirely new design from the ground up. And when you first see images of it, you'll likely have a sense of déjà vu. That's because, much like the iconic American B-2 Spirit and the newer B-21 Raider, the PAC-DI embraces the flying wing concept. This distinct design minimizes protruding surfaces and sharp angles that could reflect radar signals, giving it a theoretical edge in radar evasion, especially against lower frequency systems. On paper, this puts the PAC-DI on a solid footing. However, the true test lies in execution. While the design philosophy is sound, Russia faces historical challenges in consistently applying advanced stealth technologies, particularly in large-scale manufacturing. The precision required is immense. Even microscopic imperfections can compromise stealth. This leads to a fundamental question: how does Russia prioritize stealth? The prevailing view from some Western analysts is that while the US prioritizes absolute stealth above almost all else in its premier stealth platforms, Russia often sees stealth as one of several important factors, potentially weighing it against speed, maneuverability, or payload capacity. This difference in philosophy could mean the PAC-DA isn't designed for the same level of deep penetration stealth as its American counterparts. Perhaps this perceived compromise isn't a weakness, but a deliberate strategic choice. According to Professor Vadim Kozlin of the Academy of Military Sciences, Russia's modern long-range missile arsenal might negate the need for its bombers to risk deep penetration into heavily defended enemy airspace. He points to missiles like the Kh-55 and Kh-101, with staggering ranges of up to 5,000 kilometers. Imagine this: a strategic bomber that can launch devastating strikes from within the safety of its own borders, protected by Russia's formidable air defense systems. This shifts the paradigm from deep penetration to long-range standoff. If this is indeed the strategy, then the PAC-DO becomes a launch platform, a flying arsenal. And what an arsenal it promises to be! Russian sources indicate the PAC-DA will carry a diverse array of both nuclear and conventional weapons, all housed internally to maintain its stealth profile. Among these hot commodities is the formidable Kh-47M2, Kinzhal hypersonic air-launched ballistic missile. This beast reportedly boasts a range of over 2,000 kilometers and can hit speeds exceeding Mach 10. That's over 12,300 kilometers per hour. To put that in perspective, Mach 10 is fast enough to travel from London to New York in about 30 minutes. It can carry a conventional or nuclear warhead, with the latter potentially packing up to 500 kilotons, over 30 times more powerful than the Hiroshima atomic bomb. Russia confidently claims the Kinzhal is unstoppable by any current US air defense system, a claim echoed by some US defense officials who acknowledge the significant threat posed by hypersonic weapons. Furthermore, Russia announced another long-range hypersonic missile, the Kh-95, which is also designed to fit within the PAC-DA's weapons bay. One of the most intriguing aspects of the PAC-DA's rumored design is its expected subsonic speed. To some, this might seem like a step backward, especially when Russia already operates the impressive supersonic Tu-160 Blackjack bomber. However, this could be a calculated decision. Supersonic flight, while exhilarating, comes with significant trade-offs. The immense friction at such speeds generates a colossal amount of heat, creating a massive infrared signature that can be detected by enemy sensors hundreds of kilometers away. Imagine trying to stay invisible when you're essentially glowing like a hot coal in the sky. Beyond the heat, supersonic flight is a massive fuel guzzler. Running engines in afterburner mode for extended periods drastically reduces range and can even put the aircraft at risk of not returning to base. So while a supersonic dash might be useful to quickly traverse dangerous areas, it's not conducive to long-range stealth operations where endurance and subtle evasion are key. By opting for a subsonic design, the PAC-DA aims for greater fuel efficiency, extended range, rumored to be 12,000 kilometers without refueling, more than a quarter of the Earth's circumference, and a significantly reduced thermal signature, all while still carrying a substantial payload of up to 30 tons. This suggests a philosophy of patient, persistent presence rather than rapid, vulnerable bursts of speed. The global stealth race, B-21 Raider and H-20. The PAC-DA isn't operating in a vacuum. It's part of a high-stakes global stealth bomber race, and its competitors are already far along. At the forefront is the US B-21 Raider, described by Military Watch magazine as a true work of art and potentially the most dangerous bomber in the world. Beyond its stealth capabilities, The B-21 is envisioned as a central node in a mixed combat formation, using artificial intelligence and powerful computing to process vast amounts of data, issue commands, and designate targets for frontline fighters. While the PAC-DI is still largely in the design phase, the B-21 is already taking physical form. By September 2021, Northrop Grumman reportedly had 5 test prototypes in production at their Palmdale facility in California, with the first operational aircraft expected as early as 2025. This clearly demonstrates the U.S.'s significant lead in this critical area. Not to be outdone, China is also a major player with its Xi'an H-20 stealth bomber. Announced in 2016, the H-20 is expected to be operational within the next 2 to 3 years, with testing reportedly commencing in June 2021. This aircraft is crucial for Beijing's strategic nuclear deterrence and its ambitions for global power projection. Like its American and Russian counterparts, the H-20 adopts a flying wing design and is intended to extend China's strike capabilities across East and South Asia and the Western Pacific, allowing its existing bomber fleet like the H-6K, H-6N, and H-6J to remain within safer distances while deploying long-range, conventional and potentially ballistic missiles. For all the talk of cutting-edge technology, it's crucial to remember the human element. My uncle, a former Air Force engineer, often used to say, "The most advanced machine is only as good as the hands that build it and the minds that command it." He'd share stories from his career about the meticulous, almost obsessive attention to detail required in aircraft manufacturing, how a single misplaced rivet or a microscopic flaw in a composite material could compromise an entire system. He once recounted a story from early in his career, before the widespread use of advanced simulations, where a prototype suffered an unexpected aerodynamic instability during testing. It turned out to be a minuscule error in the application of a surface coating that disrupted the airflow in a way no one predicted. It was a costly lesson, but it hammered home the absolute precision demanded by aviation, especially for stealth aircraft. This real-world complexity is why the claims about the PAC-D being just drawings, or its stealth capabilities being uncertain resonate so strongly. Building a true stealth bomber isn't just about conceptual design. It's about mastering every step of the production process, from materials science to assembly line quality control. Russia's historical challenges with mass-producing complex, high-precision systems are well documented, and this will be a critical hurdle for the PAC-DA to overcome. Will they be able to bridge the gap between ambitious blueprints and flawless execution? Only time will tell. The development of the PAC-DA isn't merely about building a new aircraft. It's a profound statement in the ongoing strategic competition between global powers. A truly capable stealth strategic bomber acts as a powerful deterrent, capable of projecting power deep into adversary territory and neutralizing critical defense infrastructure at its most fundamental level. It's a key piece in the grand chessboard of international relations, influencing everything from regional conflicts to global stability. For the United States, the PAC-DA represents a significant new challenge to its long-held air superiority. While the B-21 Raider appears to have a considerable head start and more advanced features, the emergence of any new stealth platform from a major adversary demands attention and adaptation. For Russia, the PAC-DA is a bid to regain perceived parity in a crucial domain, showcasing its technological prowess and reinforcing its position as a military superpower. But as we've explored, its ultimate effectiveness hinges not just on its design, but on the practical realities of its stealth capabilities and the ability to bring it into widespread production. So what's the big takeaway from Russia's ambitious PAC-DA project and the ongoing global stealth bomber race? It's a powerful lesson in adaptability and the constant evolution of military strategy. In an age where technology advances at lightning speed, the concept of superiority is fleeting. Every nation is pushing the boundaries, learning from past mistakes, and innovating to gain even a fractional edge. The very definition of what makes a bomber dangerous is shifting, from raw speed to stealth, from deep penetration to standoff strikes, and now to integration with AI and hypersonic weapons. The PAC-DA, regardless of its ultimate performance, symbolizes this relentless pursuit of advantage. Whether it emerges as a true spirit killer or a more niche long-range launch platform, its development forces every major power to reevaluate their defenses and strategies. The skies are becoming an increasingly complex battleground, and the shadows they cast are filled with both formidable machines and unresolved questions. What do you think? Will the PAC-DA live up to its hype and truly challenge the established order? Or will it remain an ambitious concept, struggling for practical realization? Share your thoughts in the comments below. Let's keep this conversation going. And if you found this deep dive into the world of stealth bombers fascinating, don't forget to hit that like button, subscribe, and ring the notification bell for more insights into the cutting edge of military technology. Thanks for watching, and I'll see you in the next video.